Okay, in this video we are going to talk about division of complex numbers. Now, if you are given two complex numbers and if you are asked to divide them, what are you going to do? Okay. Now, before that, we are going to talk about one simple rule, right? This is how you divide two complex numbers. Okay, so if you have a complex number 1, this is z1, and divided by another complex number z2, right? Now when you are dividing them, you are basically multiplying the numerator and the denominator by the conjugate of the denominator, right? You can see z1 is being multiplied with z2 and a hat on top, right? Then z2 is multiplying by z2 and a hat on top. Now what does this hat means, right? You must be looking at it. You have z2 here and z2 here, but this z2 is different. It is having a hat on top, right? Now this is called the conjugate, right? When you have a complex number and on top of that having a hat, that is known as the conjugate of that complex number, right? So z2 and z2 having a hat, so z2 and z2 conjugate, z1 z2 conjugate, right? So that means when you have two complex number being divided, you multiply by the conjugate of the denominator, right? Okay, so I've written here z2 is the conjugate. Okay, so take note of that. That is what we are going to do in this video. Okay, now let's look at some examples and let's see if we can divide them. Okay, so first one, you can see a complex number, right? 1 minus 5i and minus 1 plus 3i. Now any complex number will have the form of a plus bi, and both of them are having the form, right? And if we say in complex number term, this is in rectangular form, right? A plus bi, right? So we are going to divide them. So first complex number, then you have a line here called the division line and divided by another complex number. Okay, so we're going to divide. Now what does the rule say? The rule says we are going to multiply both of this by the conjugate of the denominator, right? So I'm going to rewrite that again, right? Let's not manipulate the original question. Okay, so we have 1 minus 5i, and that is being divided with minus 1 plus 3i, right? So I am going to multiply both of this by the conjugate of the denominator. Now when we talk about conjugate, we basically change the sign here, separating the real and the imaginary part. Okay, so that means if I will multiply this, I will have minus 1, and instead of plus I'm going to put a minus, right? And 3i. Now that becomes the conjugate of the denominator. Likewise, I'm going to multiply this one by the conjugate of the denominator. So that is what we mean by multiplying both the numerator and the denominator by the conjugate of the denominator, right? Now from there we can carry out the steps. Okay, so let's put this in brackets, right? Let's put them in brackets so that it is easier for us to evaluate. Okay, now we are going to carry out the steps here, the multiplication steps, right? So we have two brackets here and we are going to basically expand them. So this is going to multiply with that, and then it is going to multiply with this, then you multiply with this, and you multiply with this, right? Okay, so you have 1 with negative 1, right? So 1 times negative 1 is minus 1. right? 1 times negative 1 is minus 1. So you'll have minus 1, and then 1 times negative 3 is minus 3, and I will come here, right? Then you have negative 5i times negative 1. So negative negative will give me positive 5i, okay? And then negative 5 times negative 3 will give me positive 15, and this I times I will give me I squared. Okay, now we are going to move on to the denominator part. Now denominator part, we can also carry out the same steps like we did for here, right? We can just expand like that, but there is a simple way of doing it, right? Now if you observe this closely, you can see that you have something as a plus bi, I mean a plus b, okay, a plus b, and you have a minus b, right? Now when you have something like z, okay, when you have something as a plus b and a minus b, that can be written as a squared minus b squared, right? We know that from the basic algebra. Okay, now we are going to use the difference of two square rule here at this place. So we will say we have a plus b into a minus b, and that can be written as a squared minus b squared, right? So instead of expanding this, right, we are just going to use this difference of two square rule. Okay, now if we do that, if I take a and square it, so a is basically negative 1 and square it, then you put the minus sign here, and you take your b term, which is 3i, and you square it, right? Now from there you can simplify this now, right? You can simplify this. Okay, so you have minus 1, right? You have minus 1 here, and minus 3 plus 5 is same as plus 2i, right? And this plus 15i goes here. Okay, okay, the denominator part, 1 squared is same as 1, this minus comes here, and 3 squared is 9, and I squared is just I squared. Okay, now things are getting simple, so we are going to simplify that more. So we have minus 1 there, plus 2i, and this I squared can be replaced as negative 1, because we know that I squared is equal to minus 1, right? That is from the imaginary number I, right? So we are going to replace I squared with minus 1. So this will be plus 15 into minus 1 over 1 minus 9. I squared will be replaced by minus 1. So minus 1, right? Now from there we can further simplify. Okay, we can further simplify that, and we will have this side as minus 1 plus 2i, and 15 times negative 1 will be minus 15 over 1, this minus and this will become plus, right? So from there we can take these two, because these two are like terms, right? So we'll have minus 1 and minus 15, right? Minus 1 and minus 15 will give us minus 16. Okay, so minus 1 and minus 15 will give us minus 16. We'll get minus 16 here, and we have plus 2i, right? So minus 16 plus 2i over, we have 1 plus 9, that will be equal to 10. Okay, okay, so now from there we can simplify this. So it will be minus 16 over 10, right? But all these are equal statements, and we'll have plus 2i over 10, right? Just breaking down this. So 16 divided by 10, this divided by 10, right? Now if we do that, if I simplify this further, I will get minus 8 over 5, and if I do 2 divided by 10, that will be plus 1 over 5, and this I is going to go there, right? So this is our answer when we divide the two complex numbers, right? And this is in the form of a plus bi, right? And which is called the rectangular form. Okay, so that is how we divide two complex numbers. Now let's do another example and see what we can do here. Okay, now example 2 is similar to example 1, but the only difference here is we have another constant here. Okay, we have two complex numbers and another constant here, 3. So if we do the calculation here, this will be a bit different from example 1, right? First we have to make two complex number, right? Currently we have two complex numbers, but we have another constant here, and this constant can be written as a fraction as well, right? So let's do this and see how we can proceed with the steps, right? So I'm going to write this again. So this will be same as 4 minus 3i over 3 plus 2i plus 3, right? Now this 3 can be written as 3 over 1, right? 3 over 1, it can be written as like that. Now when you have two fractions, you should know from basic algebra, when you have two fractions with different denominators, and if you have addition or subtraction sign in between, then you have to make the denominator same, right? So I'm going to make the denominator same here. So I will cross multiply, and I'm going to multiply the denominators. Okay, now when I do that, I will have a common denominator. So the common denominator will be this times that. So we'll be having 3 plus 2i, and then 1 multiplying with 4 minus 3i, you'll get 4 minus 3i, right? And then you'll have a plus 3 into 3 plus 2i, right? Now from there, what you're going to do, you're going to simplify those things. So you'll have 4 minus 3i, and then you have a constant outside the parentheses, so it is going to distribute in. So 3 by 3 will be basically 9, and 3 times 2 will be plus 6i, right? And then everything is going to be divided by 3 plus 2i. Okay, okay, from here look at some like terms. If you can collect like terms here, so looks like 4 and 9. So 4 plus 9 is 13. Okay, and 6, and this minus 3 plus 6i will be plus 3i. Everything divided by 3 plus 2i. Okay, now we have two complex numbers, right? So the whole purpose of doing all this manipulation here was to get this, was to get two complex numbers, right? Now what we can do, we can basically use this rule, right? We are going to multiply both of this by the conjugate of the denominator. So we are going to multiply both of this by the conjugate of this, right? So if I do that, that will become times 3 conjugate of the denominator. We are going to change this sign, so minus 2i, 3 minus 2i, right? Now the things are very simple. You are going to carry out the same steps like you did for example 1, right? So let's do that on this side. Okay, so if I do that, I will get, let's see what we have this side. Okay, let me just rewrite this here so it is visible. So you have 13 plus 3i, that is what we had. Then we multiplied by the conjugate 3. What I'm doing is I'm just rewriting this again, 3 minus 2i, and this side you had 3 plus 2i plus 2i. I'm just putting inside the bracket, and then we have to multiply that with 3 minus 2i, 3 minus 2i. Okay, so just multiplying by the conjugate. Okay, so use the expansion, right? Okay, so if I do that, I will be getting something as let's see, so 13 by 3 is basically 39. Okay, so you're getting 39 here, and then 13 by minus 2i, you'll get minus 26i, and then 3 by 3 will be plus 9, and then with the I, and then 3 times 2 is 3 times negative 2 will be minus 6, and then I times I will give me I squared. Okay, everything is divided by, again we have a plus b, a minus b. So you know from the previous example, right, when you have a plus b and a minus b, that is same as what, a squared minus b squared, right? This rule. So again we're going to use that rule here, a plus b, a minus b, so that is same as a squared minus b squared, right? Okay, let's clean this up. So you'll have let's see if we have any like terms here. So looks like 39 does not have any now. Then 26 and this, oh yes, so we have minus 26 plus 9, that will be minus 17 I, and let's just replace it here, okay, just to avoid some steps. So I square will be equal to minus 1. So let's put that there, minus 6 into negative 1, right? We know I squared is equal to minus 1, and then we have our denominator, of course, 3 squared will give me 9, and then minus 2 squared will give me 4, and I will give me I with square, so I square, right? Again we can simplify this further. So we have 39 minus 17i, minus 6 times minus 1 will give me plus 6 over Now this part will give me -1. I squared is -1, so we will have basically 9 minus 4 times I squared is -1, right? So let's do this side. So you have 39 minus 17I plus 6. So 39 minus 17I plus 6 over 9 9 minus 4 times -1. That will give me plus 13, right? Plus 13. All this will give me 13. So because this is 9 minus -4, right? Minus will become plus. Okay, so that is why we have 13 here. All right, 39 plus 6 is a like term, right? So if you do 39 plus 6, you will be getting basically 45, and then this side you will have -17. Right, divide this by 13, right? So further simplify this, you will get 45 over 13 minus 17 over 79 over 13. Okay, so that is your final answer, right? I don't think so there is a simplest fraction for this, right? This is the simplest fraction, and if you want to write in decimal, so that will be 3.46, right? 45 over 13 same as 3.46, and 17 divided by 13 is same as 1.31, and then of course the I will come there, right? So that is the answer in decimal, right? So all of them is in the form of A plus BI, right? And that is called the rectangular form. So basically that is how you divide two complex numbers, right? And take note, our general rule is you have to multiply by the conjugate of the denominator, right? Okay.